All right, let's do common table expression, or CTE. This is just the basics. I'm going to cover it first. It's a way of doing a subquery. So like here's a standalone query, and it happens to be a windowing function where we're doing the over clause and we're partitioning. And we're partitioning this particular data set by the ID here. And what we want to do is we want to take this value column and we want to do a running total. But then what we want to do is we want to eliminate the rows where the total is over 1,000. Now we could do that by just doing a group by and a having clause in the middle, but let's say for some reason we can't do that. Then we can feed it to an exterior query. We can do this as an interior query and then do this as an exterior query where we're going to then look at the running total column that we're putting the aggregate into, um, and this interior query becomes this. This is how we're aliasing it. So that's the thing about the CTE is it has this with clause, and then you do your alias as this interior select statement. So it's sort of like a subquery in reverse. Typically, you would have like a subquery and then you would alias it as something. But with the with clause here with the CTE, it's a little backwards. You do your with and then you do your alias and then you say as and then you have your object. And once we do that, we can now use this here as a table. And this gives us a lot of powerful things because this is completely materialized once from the inside out. So now when we use this, but we can also go back and forth between the two. So let's try something. Let's look at something a little more complicated. Here we've got the with CTE, our CTE name as, but now what we've got is we've got two queries on the inside and we've unioned them. So then when we use this here, we're dealing with the union of these two, the data set from the union of these two, but it's even more complicated than that because we're actually calling the CTE from inside the CTE, and then we're using it again. So this actually acts as recursion. And in this particular table, it's an employees table where it's got one of those columns where we have the manager ID. So we have the employee ID and then the employee's manager. And what this does is it recursively takes the employee ID, so you would feed that in with like a parameter, and then it's going to use the recursion to keep digging down as to whose manager is manager, so that 9 has a manager of 5, 5 has a manager of 2, 2 has a manager of 1, 1 doesn't have a manager, and because we don't return a record set, it automatically stops running, so we don't have to worry about that. And then we have this column where it's distance, so we're automatically incrementing that with each recursion. Okay, so let's look at some more stuff here. Okay, in a nutshell, what we're doing is we're feeding a select statement into another select statement, or you can even use it with data modification statements as a table instead of using a subquery or a temp table. It allows result sets to be combined with less restrictions than a union. Recursive CTEs allow row operations, which are much more efficient than cursors. Similar concept to a derived table in the sense that it's a named table expression that is visible only to the statement that defines it. Also, it is easier to read and understand than the equivalent nested subquery. You don't nest CTEs like you do derived tables. If you need to define multiple CTEs, you simply separate them by commas. Because the CTE name is assigned before the start of the outer query, you can refer to multiple instances of the same CTE name, unlike derived tables. See, that's what I was talking about here, where it's kind of reverse. This is up front, and that's on purpose. That way, this can be used down here. If it was secondary, then you'd have to wait for this to run, and then it would get assigned, and then you wouldn't be able to do recursion because as this is running, it would hit this, but it hasn't defined that yet. If we had as CTE name here, then it would start running this before we get to the alias. So because we alias it first, then we can use the alias inside here for recursion. Okay, only the scope of the statement that defines it after the statement terminates, the table expression is gone. You don't have to create and then destroy a temp table. You can use functions that are not allowed in a data modification statement, like you can use top in your CTE, which is inside your delete statement, which you normally couldn't use inside a delete statement. A CTE is defined with the with, which contains the select statement and generates a valid table expression, and an outer select, update, insert, or delete statement that refers to the table expression in the with clause. So in this particular example, is another simple example where we just have the with and then the name of the CTE. In this case, we have a list of columns, as, and then here's the interior select statement, and then here's the exterior statement where we're using the CTE. And in this case, you could have just put it together because this one's so simple. But here's one that's not so simple. Here's one where we actually have a with, and we're just with A, and that's because we're going to do a B and a C. So you can have multiple CTEs. All you have to do is put a comma between them. So this is like a with A, with B, with C, but because it's like we're doing a declaring variables and then like putting a comma between each one instead of putting them on a separate line. It's the same thing. We only have to say with once, and then we can say as, A as, B as, C as, and then we can say select star from A, union all, select star from B, union all, and this way we can do things like use tops. If we took these out and just union them together, we wouldn't be able to use the top. You can't use top and order by in each one of these. You couldn't say top to order by because union all doesn't allow you to use the top, and you only can use order by in the very last one. So here's an example where you can't do that without it. Okay, and then here's an example where we're using delete. We're deleting from this table, but this is our common table expression. So we got the with oldest orders as, and then we've got a select statement that finds the oldest orders, and then that gets fed out to our delete statement. So now we can write complex delete statements, while before we were very, very limited as to what we could put in a delete statement. And then this gets complicated. This is that same recursion, not the same one, but a different one, recursion one. But you can see you have the with, and this tries to explain it. A recursive CTE expands the definition of the table expression and consists of an anchor query, which is the source of the recursion, and a second query, which recurses across the anchor query. The two are joined with a union all statement, which is required. An outer query, which references the routine and specifies the number of recursion levels. So here, let me separate this out. You've got this is the anchor query, and then we union that with a second query that recurses through it. So see, it's calling the CTE, which is CTE, so it's calling itself. And that makes it recurse. And then we're outputting that recursion here by using the CTE. Okay, and let's see. This is a real big one here. And this is the one I went over with the manager IDs. The anchor member returns a row for 9, for employee 9, and then the recursive member is invoked repeatedly, and in each round joins the previous result set with the employees table to return a direct manager of the employee from the previous round. The recursive query stops as soon as it returns an empty set, in this case, after not finding a manager of the CEO. Then the outer query returns the unified results of the invocation of the anchor member, the row for employee 9, and all invocations of the recursive member, all managers above employee 9. Okay.